Hi, welcome to this learning talk about the effect of non-Keplerian MOID evolution on preliminary keyhole analysis. This is a modification of the close encounter theory to include gravitational perturbations of the MOID in the computation of keyholes. What are keyholes? Keyholes are regions around the planet such that if the asteroid crosses them during a flyby, then there is a future collision with the planet. We study them in the B-plane, and if we use the oblique frame coordinates, then we have G as our MOID, the minimum distance between the orbits of both the asteroid and the planet, and zeta is the timing of this particular flyby. If there's a future resonant encounter, it means that this encounter happens after k periods of the planet and h periods of the asteroid. For example, if we select a point in the resonant circle k equals 7, it means that after 7 years and after 14 years, there's this resonant encounter. Using also the condition that during this resonant encounter there's a collision with the planet, we find the keyholes. And this is this condition using the gravitational focusing factor of the planet, and we can split the condition in the MOID and in the timing. This MOID is usually assumed to be constant, but we can include a perturbation that we can compute with these two models. We use the secular perturbation by Jupiter, an analytical solution, and then we can use also numerical integration, including the gravity of the other planets of the solar system. This example is the propagation of the MOID in Earth radii during the next 20 years, starting from one particular point in a keyhole. What we see is that this variation of the MOID can have orders of magnitude similar or way larger than the radius of the planet, which means that it will cause a translation in the location of our keyholes. We can observe this by looking at a particular resonant circle and computing the variation of the MOID, of the G coordinate, over all the points of the resonant circle. What we find is that we have an initially larger MOID, but then there can be this variation of the MOID that can cause the keyholes to be in different locations and shapes. And this is exactly what we did for the flyby of 2021 PDC. We find that this combination leads to different shapes and positions of the keyholes, and then depending on how we compute this variation of the MOID, this can be very different. Now, if you have questions or comments, please reach us or read our full paper in which you will see more details on all of the results that we're showing. And thank you very much for listening.